All right, today this video is going to be about our introduction to Unit 8 material, and I also will be describing an activity that we are not able to do anymore that will kind of come up throughout these notes that we're about to take. So we're going to start with a little bit of intro with 8.1. Just want to quickly review. So far we've actually been looking at descriptive statistics. That was something that we spent a lot of time in first semester when we looked at means, standard deviations, 5-number summaries, stuff like that. And then we also made graphs of that information. We looked at different various types of visual displays that you could use, and you can see a couple of those below. But then we started to switch over to something called inferential statistics. And so last chapter we did that by estimating population parameters, where we were estimating like a population mean or population standard deviation. And so we created a confidence interval to get that estimate, that range of values. So with the population proportions, you would estimate using your sample proportion, and then you had to use z-scores. For that, I did not use my stylus very well. And then we also looked at population means. If we knew our standard deviation, then we could use z-scores for that. And then if we didn't know it, then you had to use your sample standard deviation, and then we learned our new t distribution as well. And that was all for confidence intervals. Well, we're going to continue with that. Oh, and then we skipped this. That was going to be something we looked at after our test, but I have chosen to skip that material, and so we are going to just ignore that. So now what we're going to do is we're going to switch gears a little bit. We're still going to be looking at this inferential statistics, which is once again just getting sample data to generalize and make ideas about the whole population. We're going to learn a big idea that we're going to take with us for a few more chapters, and that's this idea of testing a hypothesis. And so we're going to learn some steps to testing a hypothesis or an idea. And so the first thing is a hypothesis. You've probably heard that in science before. It's just a claim or statement that you're making that you're kind of hoping is true or guessing. This is going to be some kind of a statement or claim that we're thinking is true about our population, whether it's a proportion, the mean, or standard deviation, which once again we are skipping. So this is called a hypothesis test, but it is also called a test of significance. And I can't remember right off the top of my head right now which one your book prefers or uses more often. But basically, we're going to be learning a bunch of steps that create this test of significance, and it's just a procedure. All right, so a bunch of steps of procedure to kind of decide if this claim is true or not. So the main idea is based off of this rare event rule for inferential stats. It's basically, hey, if I am going to assume the hypothesis is true, then we're going to figure out, hey, what's the chance that I'm going to get the observed event? So what's the probability I'm going to get this proportion or percentage? And if it's a really small probability, I'm going to get that. Maybe we're going to think that, hey, my hypothesis probably isn't true. Maybe something else is actually going on here. I think I gave an example before in class, like with shoving a bunch of marshmallows in your head, or not in your head, excuse me, in your mouth, and how many can you hold? So if I claimed I can put 20 big marshmallows in my mouth, and then I actually only get 10 in, and that's going to be basically, hey, if I really got, say I have 20 in and I only got 10, the probability of that happening is probably super small, that I probably think that, hey, that claim isn't really accurate or true. So this says an example from our introduction to hypothesis testing. This was an example that we were going to do in class as a demonstration. The idea was that I was going to create a fake deck, a deck of cards, a standard deck of cards, where all of the cards were going to be red. And then I was going to have you guys kind of think about, hey, what's the probability of picking out a red card? But you wouldn't know that I had a deck of only red cards, so you would have said 50% chance, right? 50% black and 50% red that make up the deck. So that's why we're going to have this. First, we assume the deck of cards had this probability, 50% chance for picking a red card. So then I would have had someone come up and pick out 10 cards, like one card, pick it out, decide if it was red or black, and then replace it. I would shuffle again, and then you do that 9 more times. So we got a total of 10 samples. And then after that, we would have said, hey, what do you think? Is this likely to happen? Could it happen? That kind of idea, and kind of get us in this idea of creating these hypotheses. So if I really did get 10 in a row, it still is possible that you could, if you had a standard normal deck of cards, you still could get 10 red cards in a row. But that probability is super small. It's not negative. That's just like a dash there. It's 1 out of 1,024. So really, really, really small probability. So because it's such a small probability that I would get those 10 red cards in a row, that we're going to conclude that, hey, it's probably not accurate that there's 50% of my cards are going to be red. That's probably not correct. And then I would have shown you the deck that, hey, it really is not a correct assumption in this case. In fact, the whole deck was red. So then we're going to get into a little bit more detail of how to find and do this procedure called the test of significance. So these are the main steps of a hypothesis test. It's called PHANTOMS is the steps. It's just an acronym to help you remember, because yes, it is a lot of steps in this. So the P, and we're going to learn all about how to do each of these in detail. So I'm just going to quickly do an overview first of all. The P is naming the claim about the parameter. So what are we kind of trying to discover, learn about, etc. Then we're going to state the hypotheses. What is the claim? What do we think is going on? We're going to make sure verify the assumptions. Those are those requirements. Remember how we did check requirements for when we did a confidence interval? Like, for example, is it a simple random sample? For proportion, did it meet the bins requirements? That kind of stuff. Then we're going to have to name the test. That's going to come in play as we continue in the chapter, because we're going to have multiple types of tests. We're going to do ones for if it's a mean or a proportion, that kind of thing. We're going to get a test statistic, which is just going to be our z-score or our t-score. Then we're going to learn how to get either a critical value, which we've learned kind of how to do, but how to do it for tests we haven't, or a p-value, which is just the probability of something happening based off of our sample results. And then we're going to draw our conclusions and make sure we state that conclusion in the context of our situation. So you kind of did that with a confidence interval when you're saying, hey, we're 95% confident that, but it had to explain what you're representing. Hey, the means of this or proportion of that. So we're just going to spend time on the P and the H over today, and then maybe a little bit of tomorrow. So parameter, the parameter is going to always be something about a population. I think when I originally introduced that word parameter, I said the P's go together. So S's, a sample, and the word statistic go together. But population and parameters go together. So once again, we have looked at proportions, P, and we've looked at means. In this case, technically, you're using the symbols for the population, and we are skipping standard deviations this year. So now to state the hypothesis. Now there's a new vocabulary word, something called a null hypothesis. A null hypothesis is, once again, what you are thinking is true, what is being claimed. So for example, if I went back to that deck of cards, I would have said that, hey, I'm claiming that it is a fair deck, a normal deck, 50% are red, 50% are black. So I'm claiming that my proportion of my population is 50%. You can do means, and then here's one that for standard deviations that, once again, we're going to skip. So this symbol, the null hypothesis, used this symbol, this H with this little 0 there. It's actually called H naught, and that's saying your null hypothesis. That little 0 is always your hypothesis. And then you're using a P or a mean. Hey, am I doing a proportion or a mean for the population? And then your value that you're claiming. And we'll obviously see examples and practice this. The alternative hypothesis is kind of what you're thinking maybe is going on, what you're going to test. How is it different from the claim? So, hey, maybe I'm thinking really there's more red cards, or there's less red cards in a deck, or maybe I just know that it's not 50% of the deck. So you can use any of those symbols for it. And so here's some notation examples of that, where I could have, if my null hypothesis was P equals 0.5, then the alternative could have been this line right here. And so the notation, notice that all of these hypotheses have H1. That's what the alternative is going to have. So the 0 is going to be for a null hypothesis, and this 1 is for an alternative. You always have to have either a P for both the null and the alternative, or you're going to use this mu mean symbol for each of them, and then we're once again skipping standard deviations. So you're going to use the same number. If this is my null hypothesis has this 0.5, then my alternative is also going to have the 0.5. If my null hypothesis had 24, then my alternative would also have 24. But generally speaking, the null hypothesis has this equal to symbol, and the alternative is using the greater than, less than, or not equal to symbols. So that's all I'm going to cover for today, and so we will learn and practice this a little bit more tomorrow.